Hi, welcome back. So this video is going to be about how you turn those individual um, EPSPs and IPSPs into a spike. So let's go ahead and dive in. All right, so each neuron receives many inputs, both excitatory and inhibitory. There are excitatory synapses and inhibitory synapses. Usually they're not on the same synapse, usually they're at separate synapses. A neuron fires, basically, when the sum of its EPSPs and IPSPs reaches threshold. Generally, for a neuron-to-neuron synapse, one EPSP and one synapse, that is not enough to cause a spike. It's different for muscles. Muscles, yes, it usually is. But neuron to neuron, no, it's not. You would need to have many summing together in order to reach threshold at the axon hillock in order to get an action potential. And we say that PSPs can sum either spatially or temporally. So spatially means over space, or temporally means over time. So what's spatial summation? What does that mean? So most neurons receive input from many locations, as I said. So we're going to see here, we have three synapses here: excitatory, inhibitory, excitatory. And so spatial summation occurs when the PSPs from different locations sum to determine the overall membrane potential. And so here, this is an excitatory synapse, and this is the EPSP it gives. And it is just, there aren't a lot of receptors here, and so it only gets you about halfway towards threshold. It only gets you about 10 millivolts of voltage change. Okay, so this dies away, nothing happens. Now let's say that both of these fire at the same time, this one and this one. They're both excitatory synapses. Now, of course, when they sum together, you would have to take into account cable theory, basically. You would have to take into account like how far they are apart and how the voltage decays between the two. But for now, we're just gonna not worry about it. And we're just gonna say that we're recording from over here, and over here, this is the EPSP we get, and it's the same for both. So in this case, right, this contributes 10 for over here, this contributes 10 to over here, and that is enough to reach threshold. And at that point, you do get a spike. So you see this, the result of this and the result of that, they were firing at the same time, and they were summing together, and they got you a spike. But what if this inhibitory one kicked in? So this inhibitory one gives you, I don't know, maybe a -5 millivolt IPSP. And this and this together, what you would get is you would get somewhere in between. So when you sum those two together, you get PSP that is somewhere in between. And also before, let's say all three of these fire, whereas when the two yellow ones fired, it was enough to give you a spike. Now that there's that inhibitory synapse, it's not enough anymore. It's just subthreshold and you don't get a spike. So this is an example of spatial summation. So question to you: if the neuron responds to two identical GABAergic inputs at location 1 and location 2, which will be more effective at inhibiting action potentials? What do you think? Okay, so first of all, the whole concept of inhibiting action potentials, what is it doing? It means that like there are lots of excitatory input on these dendrites, and that we're not even talking about, right? And they would sum together and they would try to make a spike, but you know, this one would fire or that one would fire and decrease the sum of the voltages and potentially bring them below threshold. Okay, which one will be better? Well, if you think about it, where does the action potential start? The action potential starts at the axon hillock right here. And so if you go back to cable theory, right, we know that voltage decays over distance. And so this synapse is quite far from the axon hillock, and so its voltage change will decay quite a bit by the time it gets here. On the other hand, this one is very near the axon hillock, so it won't decay as much. It will be felt with full force over here at the axon hillock. And so what that means is that this number 2 will have more kind of influence on the overall voltage at the axon hillock. And so if we're talking IPSPs, this one is going to be exerting more influence because it's closer. It won't, that inhibitory voltage change will not die out. And so it will be more effective at inhibiting action potential. So the big idea here is that spatial summation is not only affected by just like 10 plus 10 is 20. You have to take into account the distance to the axon hillock, because that is going to tell you kind of how much a change here or out here or something like that is actually going to contribute to a voltage change over here at the axon hillock, which is where it matters for initiating a spike. Okay, temporal summation. What is that all about? So that's when one synapse receives 2 PSPs, one after another, and they can sum that way. So that works because PSPs last a lot longer than action potentials do. And so by the time you get a second action potential, you still have a little bit of voltage left, maybe if they're close enough from the previous one. So here's an example here. This synapse, it fires once. It gives you this kind of voltage EPSP. It's subthreshold. Okay. What about this? So what it's going to do, instead of just one action potential, it's going to happen twice. So you're going to have one action potential, and it does start to decay, right? Because of cable theory. Over time, current voltage decays. Okay, so it starts to decay. And also the channels open and they start to close again as the neurotransmitter diffuses away or is recycled or whatever. And then, but hey, by this time, the refractory period is over in the presynaptic cell and there is another action potential, and you don't start from here at the bottom, you start from here and do your voltage change. And so at this point, that does put you above threshold. They were able to sum, it puts you above threshold, and you're able to get a spike. So that's an example of temporal summation. The question, the drug diazepam increases the time that the GABA A receptor is open when GABA binds. Will this make it more or less likely for a given GABA IPSP to be temporally and or spatially summed? What do you think? Okay, so the answer here is more likely for both. So the IPSP is around for longer, so it has a greater chance to overlap with another PSP either at the same synapse, would be temporal summation, or at a different synapse, which is spatial summation. Okay, that is all for this topic, but the big idea here is that the PSPs add together, and if they are above threshold, you get a spike, and if not, they aren't. And that you also have to take into account how voltages decay over space and time when trying to add these things together. All right, cool. That's it for this week, or this day.